session on automated wood chip and biomass heating. My name is Grant Rawcliffe and I work for Heisemat Canada, where we obviously sell wood chip and biomass boiler systems. So I'm the one that's kind of been delegated with giving you this presentation to teach you a little bit about how these systems work and help you figure out if they might be a good system for you. So let's talk about the Canadian winter. It's not something we typically look forward to in Canada. It's very long, it's very cold, which means that heating can get pretty expensive pretty fast. So you're left with a couple of choices if you're not on natural gas or some super cheap hydro. You're left with pretty much propane and oil, which can be very, very expensive, or you're left spending your time loading a cordwood boiler or an outdoor furnace with wood a few times a day. And yeah, for smaller operations, you can definitely save some money burning wood versus burning propane and oil. But it's a huge amount of time involved. You've got to think about all the time that's involved with cutting the wood and splitting the wood and stacking the wood, and then during winter you've got to load that boiler 2, maybe even 3 times a day. You've got to clean out the ashes, you've got to scrape down the heat exchanger tubes. It's a significant time investment in order to just keep that boiler running reliably and producing the heat that you need. I actually calculated it once compared to the savings that I was actually achieving compared to propane, and it worked out that my hourly rate was less than $5 an hour. I don't know about you, but I can think of a lot more productive ways to spend my time than that. For larger operations, burning wood becomes even less practical. Just the amount of wood that you need to prepare, and then you've got to find enough storage space to keep it dry during winter. And then you've got to load that boiler constantly and manage it and make sure it operates reliably. The consistency and reliability of the heat is just not there for large operations. And that's why a lot of larger operations just resort to paying the high cost of propane or oil because it's convenient and it's a reliable source of heat. That's where wood chip and biomass heating systems have a huge advantage. Whether you have a small operation or a large operation, you can burn very low cost fuels so conveniently and so reliably that you don't have to sacrifice your time and you don't have to deal with all the hassles associated with burning wood. In fact, most of our customers, when they first get their boiler, they really have a hard time accepting that there's nothing to do. They're in there every day at the start, checking on it multiple times a day. They can't believe that there really is nothing they have to do with the boiler on a day-to-day basis. So, how do these machines do so well at saving you this time and this money? Well, I'm going to start with a quick overview just so you can understand how the systems work, and then we're going to go into a tour of a working system. In the simplest terms, these heating systems are similar to your outdoor wood furnace in that they use a fire to heat water that you then use to heat your buildings. The big difference is that they automatically feed the fuel into the boiler via an auger system from a large bunker. Typically the bunker is large enough to run your boiler for at least a month or even an entire winter. And you can fill it using a loader, a forage blower, an auger, or anything else that you can dream up. In addition to automatic feeding, they also light themselves, control themselves, and even clean themselves. Not only do all the firebox ashes get automatically removed and put in a bin for you, but the heat exchanger tubes are also cleaned automatically so that there's never any need to brush them out like a cordwood boiler. Boilers burn very efficiently, in some cases up to 90%, and the only time that you might see a bit of smoke is when the boiler is starting up from cold or if you're burning something that you really shouldn't be. There are multiple levels of burn back and safety protection built in. They're also internet connected so that you can monitor the boiler remotely on your phone, maybe when you're at your neighbour's or on vacation. And in the case where something happens to the boiler that it actually needs your attention, it will send you an email. Okay, so now that you know a little bit more about how these systems work, I wanted to walk you through a tour of the actual working system. So this system here is a 100 kilowatt system. It's about 340,000 BTUs. It's currently heating about 11,000 square feet. This is the bunker on the front of the barn where the boiler is located, and it's about 4 meters by 4 meters or 13 feet by 13 feet. And currently it's around 10 feet high that we can fill it, but we can actually go up to 20 feet with this current agitator system without it causing any bridging of the fuel in the bunker. So we're going to take a look inside, have a look at the bunker system and the feed system before we go inside and have a look at the boiler. So as you can see, this is a fairly simple construction for a bunker. It doesn't need to be insulated or anything fancy, it just needs to be able to keep the weather off. It's nice if it has some ventilation in order to be able to let any damper chip dry out when it's in there. So we have two ways of loading this bunker. This front wall here is fairly low. We can load over the top of that with a loader. We can also fill using this top hatch here, using a forage blower connected to a tractor. So most farmers have access to something like that. We've used a bunch of different styles of forage blower, and they work very effectively at filling the bunker. That allows us to get the bunker completely full up to about 10 feet. When the bunker's full for this system, again we're heating about 11,000 square feet, we get about a month's worth of heating in winter. So this is the unloading system, which is in the bottom of the bunker. It's not very different to a silo unloading system. We have a system in the center. There's a gearbox that's running these extendable arms. The arms are sprung, and so when the bunker is full, they're actually hidden underneath the pressure plate that's in the center. That pressure plate protects them from the weight of the chip that's above. As the bunker, or as the boiler calls for fuel and the arms rotate and drag the fuel into this open auger, it takes out the center of the bunker first. That prevents bridging of the fuel up higher. Makes sure that we have a nice consistent flow of fuel. Okay, so the feed system is fairly simple. As the bunker empties, the arms extend out to draw more of the fuel in. It's a fairly simple system, but with a lot of refinement. So there's a motor inside the boiler room that drives the auger, and that drives the gearbox. The gearbox is a very heavy-duty sealed gearbox. Should never ever need any maintenance, so there's actually nothing to maintain within the bunker itself. There's also a lot of refinements that have gone in that are hard to see from here. The auger system, the flighting on the auger, there's actually a larger flight as it goes through into the closed auger system. And the reason for the larger flight there versus the smaller flight in the open auger is that it moves more fuel. So that way we never get jamming of fuel as it passes from the open auger into the closed auger. Wood chip is not like pellets. Pellets will flow nicely. You can flow them through a vacuum system. They'll flow through a funnel. Chips tend to be of very different sizes and may cause jamming and all sorts of problems. So if you're ever trying to feed wood chips through a round auger that's in a round casing, you're always going to get jamming. If you notice, it's not so easy to see here, but we'll see it inside. The auger casing is actually a square casing, and what that does is it creates space in the corners of the casing, so that as the chip moves, if it does get caught between the casing and the auger, it will actually free up as it moves into the corners of the casing. Okay, so obviously as the feed system comes through the wall, it's from the bunker, it's in a closed auger. This is the square casing that we talked about outside that allows the chip to free up as it's moving along the auger, and we don't get any jams. So the flow of the fuel comes up and then it drops down, and this is our rotary safety valve. So this is our primary form of burn bag protection. I've actually got one sitting here on the floor, which we can show you exactly how it works. It's kind of like an airlock or a revolving door. So it has 4 compartments. As you see, the chips will drop into the top compartment, the blades will turn, and then the chips will drop out the bottom. So what this is doing is it's providing physical separation. So this is our feed auger that actually feeds the chips into the boiler. So in some cases, if the boiler did happen to become positively pressurized, we obviously have ways of monitoring that and making sure that doesn't happen. But in a worst case scenario, like a power cut, if we did get fire that lit the fuel that's in this auger, we definitely do not want it getting back into this auger and into the bunker, because that would be a big disaster. So this is our primary form to block that, with a physical separation of metal blades. So we have a physical separation between the fuel here and the fuel here, so that the fire is not able to jump across. As a secondary backup system, let's say for some reason somehow that failed, we also have a sprinkler system. So this system is connected to our domestic water supply. It has a heat probe on the side. It's completely mechanical, doesn't require any electricity to operate. And if that heat probe detects any heat in the auger to the bunker, it will open this valve and drop water in to douse any fire in this auger. Another function of this rotary valve, we'll come back to that, is that if you can look a little closer, it actually has cutting blades. So we have a couple of different ways of chopping up larger chips. So there's a these blades are sharp and there's a counter knife on the side here. So when the blades turn, they will actually chop up larger chip. So here's an example. We've done a pretty good job of testing out how strong these systems are. We've put through fuel that's a lot larger than it should be. This one here is 3/4 of an inch thick hardwood. It didn't make it through the system. It actually jammed the rotary valve, but what the rotary valve does is if it does jam, it will actually protect the motor by backing off again. And it will try that multiple times. The latest software actually is an upgrade that we've had. Will actually multiple times to try and free the chip up so that it will fall into the and actually end up in many cases falling through and going into the boiler. Okay, so this is the end of the discharge auger. We have an access hatch to be able to access, so if something did jam the rotary valve as we showed you before, you can just open up this access hatch. It does have a safety switch which automatically disables the boiler in this case, because the last thing we want you to be doing is putting your hand in here and the boiler operating. So if you see, this is the end of the discharge auger. What you'll see on the side here are two blades, and as those blades rotate around, there's a counter knife on the other side here. And so if you did have some chip that was longer, what would happen is that chip would actually get broken up before it went into the rotary valve and made smaller, so that we don't get any jamming further into the system. Okay, so this is a little sampling of the discharge auger that we talked about in the bunker. You remember I mentioned that inside the bunker in the open section of auger there's a smaller flighting, and then we go to a larger flighting when we go through to the closed section. Again, it means that we move less fuel here and more fuel here, so that makes sure that we never get any jamming in that closed section of auger. On the end here, we also talked about these rip hooks, which were a little harder to see when inside the casing. So these are the hooks that will crush any larger chip against the counter knife that is attached to the auger system. You'll also notice that this is a solid steel shaft. It's very heavy to lift, and it's got a fully seam welded flighting. This is not a tack welded. So these systems have to be designed to be very heavy duty, with heavy duty motors, and they exert a lot of torque when they're jamming and dealing with the jams of chips against the auger casing. So the heavier duty the system, the less hassles you're going to have with the operation of the boiler system. Okay, so we're looking at the fire end of the boiler here. So there's a couple of things that we want to talk about. So again, this is the stoker auger, which feeds the wood chips into the boiler system. We have here, this is our electrical glow bar. And so how this works is it's like a really giant heat gun. So the air blows over the top of the heated element and ignites the chips just by superheating them. These are our two blowers here. We've got one on the side here and one here. So this one here, this one feeds directly onto the fire. It's called our primary blower. So that kind of determines the power that our boiler produces. It's kind of like a bellows that imagine the old steel workers used to use. And the more you pump it, the bigger the fire gets. The secondary blower here, this actually injects air into the sides of the fire. So there's actually holes in the fire bricks that line the fire chamber. And so that secondary air causes the air to recirculate, all the hot gases that are in the fire chamber to recirculate. That burns them again. That's what determines our efficiency. So that's how we achieve up to 90% efficiency, is by this simple recirculation of the hot air gases by adding this secondary air. So this is a good shot of the fire chamber. You can see actually on the sides of the fire chamber here, these are the holes where the secondary air is supplied. Along the bottom of the chamber you can see the chain and these little paddles here that's covered in ash. That's the de-ashing system, so that draws the fire bed along the fire chamber section, and then as the ash turns into a nice light grey dust, deposits it into the auger system, which is at the back of the boiler here. Okay, so this is the ash removal system. So as we talked about, the ash chain with the pedals will pull the ash towards the back of the boiler, and it drops down here. So you can see the ash chain here, and then it drops down into this auger system here. That auger feeds outside and into an ash bin for easy ash disposal. So in addition to the primary de-ashing system in the fire chamber that removes the main ash from the fire, we also have a system for cleaning the heat exchanger tubes so that you never have to get in there and brush them out. So for this boiler system, what we use is we actually use an auger system, and so in each of the heat exchanger tubes is an auger, and that auger is designed so that when it turns, it will actually scrape the insides of the tubes and remove the ash from the walls to keep the efficiency up. That ash is actually deposited by the augers at the end of the boiler and into the ash removal system, that same ash removal system as the fire chamber. This is actually an example here of the heat exchanger tube with the auger in it. So when the auger is not moving, what's interesting is that it actually causes the hot gases to rotate or spin. And so rather than the hot air just shooting straight down the tube, which means that the center of the air would be hot and the outside would be cooled by the heat exchanger in contact with the water, by rotating it we create turbulence, which actually improves the efficiency of the heat exchange. When they turn, they actually scrape the sides of the tube to make sure that we keep those tubes clean, which again keeps the efficiency of the boiler high and saves you ever having to go in and brush those tubes out. In addition to the two blowers that we looked at the front of the boiler that supply the air directly onto the fire bed, we have a flue gas blower which is on the exhaust. So what this is doing is it's assisting the drawer of the boiler out the chimney. The temperatures going out the chimney are not particularly high compared to something like a wood stove. They typically are around the 140 to 160 degrees Celsius range. And what this does is it makes sure that we get enough negative pressure inside the boiler. As soon as we get positive pressure, that's when we can get smoke, that's when it becomes dangerous. So we have an under pressure monitoring system on the boiler, so we're always measuring the the pressure inside the boiler. And what the flue gas blower does is it adjusts to make sure that we always maintain that negative pressure within the boiler, considering that we're supplying air into a boiler. It's all about balancing that to make sure that we keep the boiler safe and working optimally. This is the control panel for the boiler system, where you can view the status of the boiler. It's a nice visual control panel. It's all touch screen, so very easy to navigate. There's options here to change all the settings. You can set it up for different types of fuels. You can program in all the different settings like the primary blower and the secondary blower here. This is the different type of fuel that we can set up. We can set up an unlimited number of different fuels so you can easily switch between them if you've got different options that you want to burn. This is showing the set temperature, so we want the boiler to be at 82. This is what it's currently at, 74.4. So, and then up here is the status of the boiler. Currently we're at load operation of 100%, which means we're firing at full. Over here on the exhaust, the flue gas blower, you'll see that there's an O2 sensor, oxygen sensor. This is very much like in your car, and it's measuring the oxygen level. The ideal setting for us to be at the optimal efficiency is between 10 to 12%. You'll also see there the flue gas temperature. It's currently at 124 degrees Celsius. When the boiler's up to full operation and been running for a while, it will probably get up around the 150 degrees, 160 degrees Celsius. This tells us what our return temperature is and currently what the boiler supply temperature is. So the other thing about the control panel is this is where the alarms would show up. So if anything happens with the boiler, say we open one of the flaps that has a safety switch on it, or if something got jammed in the boiler or ran out of fuel, we would get an alarm on the boiler. And so this is where you would come to check what the alarm is and reset it. It's also internet connected, so if you did get an alarm, it will send an email to you on your phone so that you're very aware that the boiler does need attention. You can also log in through the internet to view the monitor remotely on your phone. So if you're away from your location and maybe you're on vacation or wherever you are, you can actually view them and see what is going on with the boiler. You can actually cycle through the different menu options here, look at the reports, look at what the boiler's been doing, look at the alarms if there are any on the screen. So as you can see, this is a Siemens control panel. These are very industrial machines. They're designed to be very reliable, very durable, and so going with a very reputable controls company is important, making sure that those controls are going to be reliable and durable and also are accessible wherever you are in the world. Alright, well I hope that tour gave you a better understanding of what's involved with these automated wood chip and biomass heating systems. It's not quite as good as being here in person, but hopefully I did an adequate job of conveying the industrial build quality behind these machines that really does make them so durable, so reliable and so convenient in the way they operate. So, you know, we're lucky in Canada because with these machines we get to benefit from 4 decades of development in Europe. Hyzomat started selling these biomass systems in 1982. It's almost 40 years ago, and you know, the demand for them in Europe is just growing at an exponential rate. The factory has run off their feet in order to keep up with demand. They have more than 40,000 boilers installed worldwide at the moment. And in Canada, this technology just makes so much sense. I mean, we're surrounded by trees and there's so much wood waste that we're actually selling it to other countries for fuel. So with that in mind, I wanted to walk you through some of the realities of owning a wood chip and biomass system so that you can figure out if this is something that might be a viable option for you. So let's start with boiler size. While we have boilers as small as 50,000 BTUs, the reality is that the fuel savings each year on a boiler that size are going to be so tiny in comparison to the cost of the system that it just doesn't make sense economically. And it really doesn't make sense until you're heating at least 5,000 square feet or around 200,000 BTUs. The larger your boiler is, or the larger your heating need, then the greater the fuel savings and the greater the ROI. So, if you're not heating at least 5,000 square feet or around 200,000 BTUs, then it's not going to make sense for you from an economic standpoint, and so you're better off to stick with your existing heating system. Next up, let's talk about fuel. While these systems will definitely burn a wide range of biomass fuels like corn cobs and corn stalks and straw and miscanthus, honestly the best fuel is definitely wood-based, so shavings and sawdust, wood chips or pellets, and usually it's pretty easy to access them. If you have your own wood lot, then chipping up the tops or dead trees is a fantastic option. We have a 30-acre lot here, we got it harvested, we sold the wood, sold the good wood, and we got 4 years of heating from the treetops. Any business that generates wood waste is another great option. Sawmills that generate wood chips and slabs and sawdust, wood manufacturers that generate sawdust, even manufacturing companies that have stacks of old pallets sitting around. They can be chipped up and you can even leave the nails in because they go completely through the boiler into the ash bin. So nothing beats free fuel, but even if you have to pay for it, it's the lowest cost fuel available. And you can still save between 50 to 70% on your fuel costs. We regularly have people coming to us with an abundance of fuel that they're trying to get rid of, or having to pay to get rid of, and asking us to help them supply it to biomass customers. But you do have to be a little bit careful about the quality of your fuel. If you end up getting fuel that has large chunks of wood or rocks or other foreign materials that ends up jamming your system, kind of defeats the whole purpose of having an automated boiler. So, it'd be nice if we had this biomass quality wood chip supply network all across Canada like they do in Europe, but the reality is we're not there yet. Now, that's part of the reason that we chose the Hyzomat brand to represent, because they have a very, very heavy duty, robust feed system that can actually handle a wider range of chip and actually has features built into it to cut up and break up larger chunks of chip. Plus, they also have their own line of wood chippers that they developed that have screens in them, very heavy duty systems that are designed for producing the perfect quality chip for biomass systems. The next thing you need is a place to store your fuel out of the weather. Trying to burn wet fuel is a really bad idea. I've been there, I've done it, I've learned my lesson. All it does is it causes a whole lot of smoke, it causes extra wear and tear on your boiler, and it takes away a huge amount of heat from your heating system because you have to evaporate all of that water in your fuel. Chip dries really fast. All you need to do is get it under some sort of cover, whether it's a roof or a tarp, just anything that would keep the weather off. So having a good plan for storing your fuel, drying your fuel, and keeping it away from the weather is really key to having a successful biomass and wood chip operating system. You also need a way to load the fuel into your bunker. A loader is a great option and definitely the most popular with most of our customers. We've also had great success with forage blowers. They have the big advantage of being able to fill to the top and the back of the bunker, where a loader tends to only be able to fill from one side. We've also had one customer that has used a grain auger in order to fill their bunker. One word of caution is they were filling it with sawdust that was basically like a little microchip. Whereas if you were trying to do that with larger chip, because it's a round auger and a round casing, you would definitely run into problems with jamming of the chip. Hyzomat also offers loading systems for dump trucks. So it consists of a large steel trough with a horizontal auger feeding into either a vertical blower or vertical auger system. These are really ideal systems for larger boiler systems where you might want to fill a very, very tall bunker. You do need space for the boiler. These boilers need to be protected from the weather, so they have to be installed inside. That typically means that they're installed in the corner of a workshop or the corner of a barn, but installing them in a shipping container is definitely a popular option. And the final point that I really want to drive home is that while these systems really do require very little attention, they are not completely hands-off. You still have to be willing to fill that bunker and empty that ash bin once a month or so. You have to be willing to do about an hour of maintenance a year on the system. And you have to be willing to invest a little bit of time learning the control panel so that you can properly manage the system. It's not difficult and it's not time consuming, but if you're looking for a completely hands-off solution, you're much better sticking with propane or oil, or maybe talking to us about finding a contractor to manage the system for you. Okay, so we've definitely covered a lot in this session, and I appreciate you taking the time to join me. Wood chip and biomass heating offers the unbeatable combination of low-cost heating, reliability, convenience, and durability. And I'm really hoping that I've done an effective job of conveying that to you today. If your interest is piqued and you'd like to learn more, then definitely give us a call or even drop by for a visit. There's so much more to these systems than we can't even cram half of it into a 30-minute session. We're passionate about these products, and with all the experience we've gained over the years, combined with Hyzomat's 40 years of expertise being a pioneer in the industry, we have a wealth of knowledge and information to share. And if you really like getting the straight goods right from the horse's mouth, well, we're happy to connect you with any of our customers from anywhere across the country. So thanks again for attending this session, and we look forward to chatting with you soon.